number 3, show that cos inverse of 3 over 5 plus sine inverse of 5 over 13 is equals to sine inverse of 63 over 65. Now to show that the cos inverse of 3 over 5 plus sine inverse of 5 over 13 is equals to that, the first thing you do, you let cos inverse of 3 over 5 be A. So you let cos inverse of 3 over 5 to be A, it implies that if you take cos inverse on the other side of the equation, then 3 over 5 is equals to cos A, isn't it? Then, and you also let sine inverse of 3 over 5 over 13 to be what? To be B, isn't it? So sine inverse of 5 over 13 to be B. So that will implies what? It will implies that 5 over 13 is equals to sine B if you take sine inverse on the other side of the equation, isn't it? So it is now it is like that. You have A plus B because the cos inverse of 3 over 5 is A, isn't it? And cos inverse of and sine inverse of 5 over 13 is B. So it's like you have A plus B. Are you seeing that? It's like you have A plus B. To go pamoja. So this will now imply that A plus B is like now A plus B is equals to sine inverse of 63 over 65. Are we together? If you take sine inverse on this side of the equation, we now have sine A plus B is equals to 63 over 65. Are you seeing that? So it means for us to show that this problem above, cos inverse of 3 over 5 plus sine inverse of 5 over 13 is equals to sine inverse of 63 over 65, then we need to determine sine A plus B. Are you seeing what we need to determine? We need to determine sine A plus B. So what is sine A plus B? That is a sine sum angle formula from trigonometry, isn't it? Yes. So sine A plus B is sine A cos B. If A is positive, the other side is also positive, isn't it? Then sine you interchange, then sine B cos A. Are you seeing that? Tuko pamoja? Yes. So it implies sine A plus B is equals to sine A cos B, then plus sine B cos A, isn't it? So what do we need to determine? We need to find sine A, we need to find cos B, we need to find sine B, and we need to find cos A. That is when we are able to get sine A plus B, isn't it? So how do we get sine A cos B, sine B cos A? We get them using a right angle triangle because already we've been told cos A is 3 over 5. Are you seeing? Yes. At the same time, sine B is 5 over. These are trigonometric ratios, meaning those are right angle triangles, isn't it? Yes. So if you take a right angle triangle, the first right angle triangle here, when you have angle A, you see, when you have angle A here, it means which side is the opposite? That is the opposite side, isn't it? The side which does not make that angle, isn't it? Then the longer side is the hypotenuse. Then this other side remains the adjacent, isn't it? So if you look up here, you'll be told cos A is 3 over 5, isn't it? So cos A is 3 over 5. But what is cosine according to Sokato, trigonometric ratios? Adjacent over hypotenuse. So if cos A is 3 over 5, meaning that is adjacent over hypotenuse. So where there is adjacent, you put 3. Where there is hypotenuse, you put 5. Isn't it? So you now use Pythagoras theorem to get the length of the opposite side. Yes. So if you use Pythagoras theorem to get the length of the opposite side, what is the opposite side? 4. Isn't it? So it means once you have all the sides, then you can now get sine A. Are you seeing that? Isn't it? So what is sine A from this triangle? Opposite over hypotenuse, isn't it? So opposite is 4 over hypotenuse is 5. So we found sine A. So it means we already have sine A and cos A. Then we go to B, isn't it? So in B, you will know sin B. We found out that sin B is 5 over 13, isn't it? So we draw a triangle for angle B, isn't it? Draw a triangle for angle B. So if angle B is there, it means this is the opposite side, and this one now becomes the adjacent, isn't it? The longest side is the hypotenuse. Then what have you been given? You have sine b is 5 over 13, isn't it? Are we together? So sine b is 5 over 13. Okay? So it means we need cos b. Sendio. So for us to get cos b, we have to relate. So sine is opposite over hypotenuse, isn't it? Sine is opposite over hypotenuse, meaning the opposite side is 5, isn't it? Opposite side is, and the hypotenuse is, this is hypotenuse, isn't it? Hypotenuse is 13. So you can use Pythagoras theorem to get the length of adjacent. So what is the length of adjacent? 12. So after getting the length of adjacent, it means you can now determine cos b. So what is cos b? 12 over 13, because cos b is adjacent over hypotenuse, isn't it? Now having determined all that, then we now come back and we look for sine a plus b, because that is what we are determining in that equation, isn't it? So sine a plus b is equals to what? Remember, substitute. Where there is sine a, you put the value of sine a. 4 over, sine a is 4 over 5 times cos b. Cos b is 12 over 13, then plus sine b is 5 over 13, then times cos a is 3 over 5. So can you use a calculator to work that out? 4 over 5 times 12 over 13, 4 times 12 is 48, isn't it? 5 times 13 is 65, then it is plus 5 times 3 is 15 over 13 times 5 is 65, isn't it? So what do you get there? The common denominator is 65. Then in the numerator 48 plus 15 is 63, isn't it? So you found that sine A plus B is equals to 63 over 65. But what do we want? We want A plus B, not sine A plus B. Are we together? So if you want A plus B, meaning you take sine the other side of the equation, isn't it? So if you take sine the other side of the equation, you remain with A plus B is sine inverse of 63 over 65, isn't it? Are you seeing that? Yes. We have sine A plus B, but we need A plus B. So A plus B is sine inverse of 63 over 65. Then you substitute the value of A. Where there is A, you put the value of A. What was A? A was cos inverse of 3 over 5. So where there is A, can you substitute the value of A? Cos inverse of 3 over 5. Then plus, where there is B, substitute the value of B. Sine inverse of 5 over 13, and that the whole of that is equals to sine inverse of 63 over 65. Have you seen you prove that using the inverse function? So to prove that concept, you simply let the first unknown, the cos inverse, the first term there to be A and the second term to be B, isn't it? Then you get rid of the inverse function on the right hand side of the equation. Then you now work them out using a right angle triangle, isn't it?